Hello everyone, my name is Roman, I'm a member of a Simple Poker team, and in this video I'm gonna tell you about the official release of our new solver, Simple Omaha. The information about the product you can find at our website, simplepoker.com. Go to the products, Simple Omaha, and here you can purchase the program, you can download it, and you can read about it. Simple Omaha is the only Omaha solver that allows you to calculate two-way spots post-flop without any abstractions. And what does it mean? Calculations without abstractions are quite precise, and we can actually see the level of precision. They are not done through the Monte Carlo simulations, but through the vector algorithm instead, where every hand is included into calculations and every possible runout of the game tree is taken into account. If you have any questions on how actually the program operates, you can ask them via Discord. The link to our Discord can be found in the description of this video, or you can send an email to support@simplepoker.com, or you can contact us via Skype. Account name is Simple Poker. You can purchase this program for $249 for 1 year and for one computer only. Here's some system requirements. You need to have at least 32 GBs of RAM, but we recommend 128 and more. 32 is actually the very minimum you need to work with this program. Okay, now let's go to the program itself, which you can download right here. Click the button Free Download, and I have done it already and also installed it. Okay, here's the interface. On the very top you have 3 tabs, File, Cloud and Standalone. We'll go through it a little bit later. Then we have an area where all the results of the calculations are shown. After we have an area where we put in all the data, the situation that we want to calculate. And on the bottom we have an area for our game trees. Let's first go through the menus. First we have File. Here you can open a model that you have saved before, or you can actually save a model that you are working with. Then you can change the update link. Why do you need this? If we present the new beta version of the program, you can actually try it out. We give the links on our website, and you can enter it here in the update menu and try it out. And then standard options, about and exit. Then we have Cloud. Here you can actually create an account on our website. If you click register, you will go straight to our website. You can create a new account, or if you are using our other products, you can use accounts from there. Anyways, right now it's not so relevant for the Simple Omaha, but we hope that in future it will be. Also we have here situations. Here we present you a few free flops that are already calculated. Just double click any of those 4 flops that you want and it will be downloaded. In the future we'll maybe add some packages with solutions for some spots, and in this case you will need an account to buy a package and download it, but for now we don't have those. And finally we have Standalone tab. Basically it allows you to do the local calculations if you have the license. And if we click on the license menu, a little window will pop up where we can actually enter our license key. And by the way, let's do it. When you purchase the program, you get the license key. And I've generated one just for this video. Let's copy it, click enter license key, paste it here and click OK. As you can see, the program is activated successfully. And right from this moment, we can start to calculate situations locally by our own, but not for now. For now, let's continue exploring the menus. We also have the settings menu right here, where we can enter the calculation parameters. For the flop, we can pick one of 5 algorithms. First 3 are vector algorithms that give us pretty precise results. And then we have 2 Monte Carlo algorithms that would actually work pretty fine for the flop and require a lot less resources compared to the vector algorithm. First, let me explain the difference between three vector algorithms, A1, A2, and A3. A1 is the most RAM-efficient algorithm. It requires 2 times less RAM by default than A2 and A3. A1 also allows us to compress the game tree for up to 4 times. We can pick the magnitude of a compression ourselves, times 2, times 3, or times 4. And if we pick times 4, it will require 8 times less RAM than A2 algorithm. We can also do the calculations using bucketing. Bucketing is when we separate hands in different groups on turns and rivers, meaning that few hands from one group will be calculated as one hand. This helps the program to use less resources. Then we have A2 algorithm. There is no compression for the A2 algorithm, and basically this algorithm is the most stable. It is faster than A1, but requires more resources. And finally, A3 is the fastest algorithm of the vector ones, but sometimes it will not converge. It will give you the wrong results, and you will be able to see it in the Nash distance. So the best algorithm here is A3, and we should use it by default. But if for some reason it doesn't work properly, if we get in the situation where it won't give us a good tree, then we choose A2. And if we don't have enough RAM, then we pick A1. And on the right, we can pick accuracy, which is basically the amount of iterations that the program will go through. Okay, let's also compare the Monte Carlo algorithms. We have EC CFR and CS CFR. We recommend you to use ES CFR, and this is the default algorithm the program uses for the flop calculations. Well, basically those algorithms are very similar, but the first one, ES CFR, is just a little bit faster. But for some complicated trees, the CS CFR algorithm will converge better. But those cases are quite rare, so we recommend you to use the ES CFR algorithm. And for the Monte Carlo algorithms, we can pick an abstraction, which basically means the size of bucketing. I mean the size of the groups for bucketing. If we pick small, it will give us less accurate results, but will require less resources. And if we pick large, the results will be more accurate, but then again it will require more resources. Usually the small abstraction is quite enough. Then for the turns and rivers, we only have vector algorithms, because Monte Carlo algorithms are much worse for the later streets, and the results are not quite precise. Also, the RAM requirements are not so high for turns and rivers, so even if we use vector algorithms, the calculations will go pretty fast. And that is why we only use vector algorithms for turns and rivers. Then we also can choose the number of threads we want to use. My CPU has 8 cores, which allows for 16 streams, but I always pick 15. For my computer not to lag as much and basically completely stop working. Because if we use all 16 threads, then we use all the calculation capabilities of our computer and we simply cannot use any other program. Next we have calculate timeout in seconds. This limits the time for the computer to upload game tree into RAM. Just in case the machine cannot upload game tree and basically stucks, we have this sort of exit point. But in the end, if you don't want to use this feature, you can set the huge number right here, and you won't have to worry about it at all. Then we have this little show intermediate Nash distance function, which only works for the vector algorithms. If we turn this function on, then we will see the intermediate precision results. so we can constantly track the precision of calculations. This slows down the calculations a little bit, and also if we turn it on, we can set the threshold for Nash distance. For example, if we set 0.1, the program will calculate the results up to this threshold of 0.1 Nash distance. Or if this Nash distance is not reached, then the program will go through all the iterations we set up here. But in this example, I will not use this feature because it slows down the calculations, as I said. Now let's go straight to the game tree building and we will go through all the parameters we can use here. First thing we do is we set up a board that we want to calculate. For example, let it be ace, king, queen of diamonds. Then we set the effective stack and the amount of chips in the pot on this flop. For example, effective stack is 80 BBs and the pot is 10 BBs. Also, if we pick turn and river cards, we can start the calculations from the turn or from the river, but since we only have flop, other options are unavailable. Next, we have to choose the sizings for both players, based on which the game tree will be constructed. And I also want to point out that we can edit the game tree manually. So we set all of these parameters and afterwards, if we want to change some of them, we can do it manually. If we click here, we see the default bet sizings, which is half pot and pot, and we also can add sizings of our own. Like here, I added this test sizing, and if we click here, we can see the parameters for this sizing strategy. We can set up the sizings for every street for both bets and raises. And for example, here we see that the pot bet is used both for bet sizings and for raise sizings. And we also can add up to 3 sizings for every street. Like if we here add half pot sizing, it means that on the flop, player 1 can choose from those 2 sizings. But he still only raises pot. And yeah, as I said, we can use up to 3 sizings for every street, but right now we don't have the goal to build a huge complex tree, so we will keep it as it is. Then we can set the maximum amount of bets that go in on one street. If we set 4, it means that we can only bet, raise, re-raise and shove. We can also add open shoving for every street, which is not relevant for pot limit Omaha, but could be used, for example, in no limit Omaha. We can also set up here that the last action will always be all in, but then again it is not relevant for PLO, so we do not touch this. Then we can round bets to the nearest number. For example, if we set 1 big blind, every bet will be rounded to 1 big blind, so that we have only whole numbers. And this parameter all in if more than a percentage of stack. That means that if our bet is larger than 70% of the effective stack, we go all in. But then again, it's irrelevant for PLO because the maximum amount we can bet here is pot. So we type in 100%. Now we can save this strategy, let's call it test 2, save it here, and now we have this sizing strategy as an option and we can pick it for both players, for example, or just for one of them. Here, as I've set it up, both players will use same sizing strategies. Next, we can choose if we want the calculations to be in a pure GPV mode or if we want to account for the rake as well. We choose rake, then we click this rake button and we set up the rake structure. The percentage of rake taken and the rake cap in big blinds. But for our example, we will go with the GPV mode. Then we choose the player who is out of position. By default, it is always player 1. And after we click Apply Situation, the program will generate a game tree. Here we see the game tree with all the sizings that are used. And for example, if we don't like this 10 BB sizing, we can change it on the spot. We right-click on the node, we choose Edit Node, and then we set up the sizing that we want. For example, 9 BBs. As you can see, we now have a new game tree. And if you want more sizings, then again we right click, we pick edit node, and we add a new sizing. Now the program will choose from two sizings, 5 BBs and 9 BBs. So yeah, we can edit the game tree manually. We can add nodes, we can remove nodes, we can adjust it the way we want. Now we have to set up preflop ranges for both players. We have some standard pre-made ranges that we have downloaded from PokerJuice. And if you have a range copied to clipboard in PPT format, then you can just click here, paste range, and your range will be pasted right here from the clipboard. Or you can right-click to open a range editing menu. First of all, we can filter hands out here by some parameters. For example, we want to filter all the hands that include 2, 3, and 4. We just click here, 2, 3, and 4. And if we will never play this part of the range, we can set that those hands will be played with 0 frequency. We pick 0 here and click apply. Now those hands are never played. Then let's say we want to play 50% of our ace 4-3-2 combos. So we choose this particular hand right here and we set it up to 50%. So we want those hands in our range, but we don't want to play them all the time. Now we click apply and we see that we actually will play half of those hands. And aside from these standard controls, we can also filter hands using the PPT syntax. If you click right here on this little question mark, then you will get straight to our website where all the syntax is explained. For example, AA, KK. These are all the hands that include 2 aces or 2 kings. And let's use it in our example. We copy paste it and apply. If letters color is changed to green, that means that the syntax was applied correctly. And as you can see, we filtered 911 hands out of 16,000. Here are all those hands, and for example, if I don't want to play these hands pre-flop, I again pick 0 frequency, click apply, and all those hands are gone from our range. So yeah, this is how you can use the PPT syntax to build a range. Then when we finish building range, we click apply, and we see this range right here, 93.82%. But for this example, let's pick another range, for example, for betting range of 4%. Now I can either start the calculations by clicking here, calculate flop, or I can click here on this get memory button to find out how much RAM is required to get through all the calculations. Let's, for example, pick this Monte Carlo algorithm with small abstraction and check out how much memory is required. So in a second we will see how much RAM will the program use to go through these calculations using the Monte Carlo ES-CFR algorithm with small abstractions or a small amount of buckets. Okay, only 7 GBs, but we have to realize that this is a very simple tree and we have a monotone board. Now let's go with vector algorithm A3 and check out how much memory we need for this one. Okay, now it's 19 GBs required. Let's now change the board from a monotone to a rainbow. Of course, we now expect to see that more memory is required, all those things, ranges, board, algorithm, all of those affect the amount of RAM required for the calculation. Yeah, here we see 63 GBs of memory. And we will not go through any calculations right now. We will just work with the solutions that are calculated already, which we can find right here. We have 4 flops, one of which we are downloading right now. Okay, here's the flop. We see the Nash distance is 0.05. which means that this solution is only exploitable by a maximum of 0.05 of a big blind, which is 5 BBs per 100 hands. Quite a precise solution actually, considering the pot size and the effective stack. Now we pick a branch in the tree and we see the results right here in this little table. Here we have the information on every possible hand, and again we can filter those hands. For example, we can only pick hands that include queen and a jack. And we see strategies for all the queen-jack combos. Also, we can filter hands using this PPT syntax, which again can be found on our website. Here we also can see the information on the groups of hands. Let's, for example, pick this node where player 1 bets and player 2 raises. Here we see three colors: yellow for calling, red for folding, and green for raising. And if we take a look at hand categories, we can see that we always call quads and full houses. And we are mixing calls and raises with our trip combos. On the left we see groups of hands, for example here ace 9 7 suited and another ace of other suit. And if we click on it, on the right we see all the specific combos of this group. And we can see all the information on every hand. For example, if we pick this exact combo with ace of diamonds and ace 9 7 of hearts, we play this hand as a call 44% of the time. And down here we can see the frequencies of all three options. And not only frequencies, but EVs as well. And we can actually use different colors to see different things. For example, here we see the strategy and colors, but we can change it to played show, which will show us how often a group of hands is played. We picked a call option, so the darker the color of the group, the more often this group of hands is called. But I think this one is a little bit strange to many people, and this strategy show is what we are much more used to. By the way, if you don't like these default colors, you can always click on a color and choose the one that you like. And if you want to come back to the default colors, you just double right click on the color and everything is back to normal. Okay, imagine that we went through the flop results and now we want to know what to do on the turn. For example, turn like 8 of diamonds. We have all the ranges here from the flop and we also have to pick an algorithm. Well, let's make it A3 with low accuracy. Same for the river. Okay. Now we click calculate turn. By the way, we could find out how much memory we need for this calculation, but it is usually not so much for the turns and rivers. Plus we have a very tight ranges and the effective stack on the turn is quite low. Okay, we get a great Nash distance, 0.007, which means that this strategy is only exploitable at maximum of 0.7 BBs per 100. Let's pick check option and river card and calculate river. And you can see how fast it is. Usually it takes about, I don't know, 10 to 15 seconds. But here we got it pretty much immediately. And again, pretty good Nash distance, even with the low accuracy, because as I said, A3 algorithm is quite fast and precise. Okay, that's the information I wanted to share with you in this basic video. If you have any questions or maybe suggestions, some feedback, please join our Discord channel and you can find link down below. Thank you very much for your attention.